Hmm. Hey, Levi, will you pull that door shut for us? Thanks, bro. Yeah. So I have like 18 things to go through. I just don't think it'll take all that long considering. So there's an order that we have to do this in. By the way, this will be the end of quadratics, and then we'll start getting into quiz mode. And I think what I'm going to do is probably quiz you guys on a couple of occasions rather than hit you with a quiz that has everything on it. That would feel more like a big unit test. I'll probably hit you with some shorter quizzes over the next week or so. So this will be the last thing that we learn as far as solving quadratic equations is concerned. And this method today is really fantastic, but it does only work. No, that's a lie. You should only use it under certain circumstances because and as you start to learn the method, then you'll be ready to ask the question of like, well, what if that's one of those? Or, and then we can talk about when to and when not to use this. Ideally, when I'm done with you, I would be the proudest if you can look at a quadratic and know what the right method is. Like I can look at that and say, oh, I can factor that, or oh, that one's terrible. I'm going to use the quadratic formula. That's the goal. You know, it's not, it doesn't always happen that way, but that's the end goal is to have you be able to look around and say, what's the best method? What's the best tool for the job? So again, today's is kind of a niche thing, but it's super nice. So I just wanted to start the lesson by having you factor some things for me because I don't think that the things that I want to talk about today will make any sense if we don't start with this. So if I ask you to factor this, you shouldn't have too much trouble. I don't think. You know that to factor it, you would put your two shells, of course, and in the fronts we would put single X's. What would my signs be? Both pluses for sure. And then what numbers are we thinking of? Good job. So starting today, it's important that we not write that answer like x plus 3 times x plus 3 because it's something times itself. How else can we write that? Squared. Of course, something times itself means squared. So the better way to write this answer is to write it like this, x plus 3 squared. That's important. That's called a square. Anything that is something else squared is called a square. So what it means is that this right here, the thing I'm underlining in purple, is called a square because it's obtained by doing x plus 3 times himself. All right, let's factor another one. So we're going to do 4 of these, all right, a total before we press into the actual lesson part. So this one again, if I said to factor this, you would start with a pair of x's. What would my signs be? Say it again. Yeah, they both have to be negatives because they multiply to make positive 25, but the minus in the middle tells us that they have to both be minuses. And what numbers are we thinking of? 5 and 5. And so once again, you see a theme here. When I factor that down, it factors into x minus 5 squared. Okay, let's go again. How about this one? So we have our shells, single x's. What are our signs? Both of them subtraction. And the numbers that multiply to make 1 would be 1 and 1, right? This lesson obviously doesn't go well if you don't know how to factor. So, I mean, we've done enough factoring that should be just like light work for you guys. And again, that answer is not acceptably written, so we would write it as x minus 1 squared. All right, we'll do one more just to make sure that the point is abundantly clear. What are my signs? Mm-hmm. And what numbers are we looking for? 4 and 4. Which again, we would elect to write this today as x plus 4 squared. Clear? Okay, so let's get into what does it mean to complete the square. So I'm going to put a polynomial up here. And I'm going to put a blank at the end. And I want it to be factorable into something squared. So I didn't know sometimes it's hit or miss, but since you have all your notes in front of you, if you were to go back and look at those 4 examples, do you see anything in the original problems? You wouldn't see it on the TV right now. Do you see anything in the original 4 problems that made them factor the way they did? There's a thing there. What do you see in there, Zane? There's more to it than that. Like, I don't disagree with what you're saying. So if you focus on, I'm going to circle some numbers in red. I don't disagree with what Zane said because that's an important part of it. 9 is square rootable. 25 is square rootable. 1 is square rootable. 16 is square rootable. But can you do a little bit better than that? Okay, I agree. They all have pluses. That's a good observation. Think about this number. The numbers that I pointed to in purple. What's the square root of 16? 4. What's double 4? Jackpot. What's the square root of 1? What's double 1? Jackpot. Let's keep going. What's the square root of 25? Double 5. You get the idea. So what I'm asking you to do here is try to think about the relationship between the number that we have in the middle of the problem and the number that we need to have at the back of the problem. Anyone have any ideas as to what I could put in this blank? Say, it has to be 36. Very good. And so if you think about what we just talked about, but you think about it backwards, really what it comes out to is I can always find the number that I need in the back to complete a square. I can always make this factorable a certain way. I'm in control of this. What I just did by putting a 36 there, that thing I wrote in red on the TV, that act is actually called completing the square. By putting a 36 at the back, I completed the square. And this thing is now called a square. And what does it now factor into? We forced the issue. X plus 6 squared. Very good. So we're going to spend a few minutes here. I've got 5 more of these. I'm going to write a problem like the one I just did, and you're going to help me complete the square. All right. And if you don't see it, hopefully you'll see it by the time we're done. But if you don't, and you just want to ask, we can, those of us that have caught on to the process, we can fill you in. What goes in the blank? I don't know what you said. It has to be plus 4. Because the square root of the red 4 is 2, and double 2 is 4. So we've made it work so that now when we factor this down, it factors into x minus 2 times x minus 2, aka x minus 2 squared. Let's go again. Nice job. I thought this would be a good time for those of you that haven't cracked the code yet to just straight up tell you what the process is. It's very slick and easy. Here it goes. You take this number, I'm circling it in purple, take half of it. What's half of 18? What's 9 squared? Jackpot. If you follow that algorithm, just a couple of little babies, half of 18 is 9, right? And then 9 squared is 81. And that guarantees that when I factor this, it'll factor into x plus 9 times x plus 9, just like that. You see it? Let's go again. One. Yes. Half of 2 is 1. And 1 squared is 1. 1. So when we factor that down, it would be x plus 1 times x plus 1. Okay, a couple more. X squared plus 20x blank. Half of 20 is 10. 10 squared is 100. So by adding 100, you ensure that this thing can be factored into x plus 10 times x plus 10. Everyone on board with this? You good? If it's already a complete square, then we don't need to do anything, right? What I'm trying to show you right now is how to forcefully, I keep doing a number in red. That's the force number. That's the number that we force to make it a square. If it's already a square, then you just factor it. Does that make sense? Yeah. You sure? Okay. X squared minus 16x. Nope. Half of negative 16 is negative 4, excuse me, negative 8. And negative 8 squared is, there you go. So adding 64 does the magic and makes sure that it's factorable into x minus 8 squared. Good? Okay. So we've worked our way up then to the point now where I can show you how this actually applies to solving an equation. And if you're a math person, I always say that because not everybody is. Some people, math just like scratches a certain itch. Some people just tolerate it. Some people hate it. But if you kind of like math, you'll like this because it's real pretty. Like the method is just nice. It'll get under your skin and make you go, I like this. So we're going to start with an equation like this. So I'm going to show you some steps now, and this is where I really need you in follow directions mode. Okay, if you follow these steps, you'll be just fine. So step 1 is to take the 9 and make sure to kick it over to the other side, which I know is weird because normally I don't tell you to do that. Normally I tell you to get everything on one side. You're like, well, we don't want it this way. So what we're going to do is we're going to leave the x squared. We're going to leave the plus 12x. We're going to leave an awkward space, and we're going to move the 9 to the other side and turn it into a negative 9. What I'm essentially doing is I'm clearing a spot right here so that I can just cleanly and simply complete the square. What is half of 12? What is 6 squared? So adding 36 completes the square, right? But if you don't want to anger the math gods, which you should never want to anger the math gods. They're a spiteful lot. You have to add 36, of course, to the other side as well. You know, you learned that about equations back in like 7th grade probably, is that whatever you do to one side of an equation, you have to do to the other side as well. So if I were to ask you a series of questions, why did we add the one with the arrow pointing to it? Why did we add that 36? To complete the square. If I ask you, why did we add this 36? Your answer is, whatever we do to one side, we have to do to the other side. So the 36 on the left was with a purpose. The 36 on the right is just to keep the balance. Okay, so far? What we're going to do now is we're going to factor down this square. What does x squared plus 12x plus 36 factor into? Good job. And here we are at the end of April, so I'm well within my rights to pretty much demand that you not mess up 4th grade addition. What is -9 plus 36? Definitely 27. And at this point, this may not look familiar to you yet, but at some point in the next 10 minutes, a light bulb is going to click on in your head and you're going to say, oh, I've done this before. We've solved equations just like this. That entire bottom section of all the snapshots you've done was on solving using square roots, and that's exactly what we set this up to be. We did it. We made it happen. So what I'm going to do now is I'm going to take the square root of the left side, which is going to leave me with x plus 6, and then I'm going to put equals positive negative, because that's what I do. And then I'm going to take the square root of the right side. And what is the square root of 27? Let's write it down and make a tree. Can you break down a 27? Yeah. Root 9 and root 3. And a couple of you have seen very recently what happens when we don't say the word root. When we say 9 and 3, then we say something cockamamie, like the answer is 9 root 3, which of course it's not. It's 3 root 3. And what's the final step? Move the 6 right there. Remember this. So x equals what? And we are done. So that is how you solve a quadratic equation, by completing the square. Let's go again. 1 down, 7 to go. I have 4 warm-up problems, and then they'll get just a little bit harder, but only a little bit. It's not bad. Let's see if you remember the steps. It's hard to ask people to memorize steps when you just go through them one time. Most people need to see it 2, 3, 4 times, but let's see. What's step 1? Good job. Move that 15. And remember, what you're doing is you're clearing a little bit of a landing pad here for completing the square. When you move the 15, it becomes a positive. And then you just go through this series of steps. They're foolproof. Look at the number in the middle. His name is 2. What's half of 2? What's 1 squared? 1. So I'm going to add 1, and the square is complete. But if I add 1 to the left, I have to add 1 to the right. Right? What does the left side factor down into? 2. Good job. You're fine. And what's 15 plus 1? Nice. Now it's time to factor. Excuse me, now it's time to square root. So when I square root this down, what do I get? Positive, negative. And what's the square root of 16? Right, so this is not one that needs a root, because the square root of 16 is just doable, right? What's the next step? Move the 1. So the 1 is going to go, right there. And this, unlike the last problem, is not done because you've heard me say this a lot of times. This is a pathway problem now. Because they're rational solutions, we want to go and actually calculate them. So trace the pathway on top. His name is plus. What is -1 plus 4? One of your answers is 3. What is -1 minus 4? And we are done. All right. 2 down, 6 to go. Feel okay with the process? So nice. You ask anyone like Mrs. Eklund or us math nerds, she'll tell you this is the best of the best. And I say it's not always appropriate to use it. One more example, and then I'll ask you the question of, now that you know what you're doing, when would it be inappropriate to use it? Think about the process. Like, let's start this problem right now. What do we do first? Move the 51, clear the landing pad. So we have x squared minus 16x awkward void equals -51. And now if you think about what we're about to do, you'll quickly, I think, arrive at a, oh, kind of moment. What's the next step? Just a little baby step. What do we do? You take that -16 in the middle and you divide it by 2. And if you were to look back at every problem that we have done so far, I keep making it so that this number is what we call even. Even is a big deal because if a number is even and you divide it by 2, it comes out nice, right? So can you do completing the square when that's odd? You can, but it's going to involve fractions, and we generally don't do, I don't think I'm supposed to do that in Algebra 1, but we might. But for today, they're all going to be nice even numbers. So that's something to think about is if I see that come in, then I might think about, I don't know if I want to use completing the square because I'd rather not do fractions. I might just use the quadratic formula, you know. What's half of -8 or -16? What's -8 squared? So I'm going to add 64 to complete the square, and then I'm going to add 64 so as to not get in trouble. What does the left side factor down into? And what's -51 plus 64? Perfection. Now we square root both sides. What do we get on the left? Equals. Right. And you cannot tree down a 13, so we can just safely just put it there. 13's trash. Last step. Add the 8, move the 8. Becomes a +8 plus or minus root 13. Done. Still good? Okay. This is our last of this flavor. You ought to know the steps by now, right? If we're on the 4th go, so I feel like it's a reasonable ask to say, okay, 4th try, you're probably feeling the groove. What's step 1? Move the 5. Clear that landing pad. So we have x squared minus 6x equals -5. And then there's just a series of steps, right? It doesn't change. Like what's half of -6? What's -3 squared? Yes, and that's always a positive, like you guys observed earlier. That red number is always going to be addition. Even if you type it in your calculator and your calculator tries to tell you that it's negative, you know that just means you typed it in wrong. Negative numbers or positive numbers, when you square them, that's always going to be a plus sign, right? So if I add 9 to the left, I have to add 9 to the right. And then I factor, what's the left side factor into? And what is -5 plus 9? Okay, so you can see already probably that this will be a pathway problem. I'm guessing that has crossed your mind already. Factor, or excuse me, square root the left, what do you get? equals positive negative 2. You're fine. Never have to be sorry for that. It's not a big deal. Plus minus positive negative, we know what you mean. But positive negative is perfect. And then let's move the 3. So we wind up now with x equals positive 3. Plus or minus 2 becomes a plus or minus now because there's a 3 in front of it. And then just trace your pathways. What's 3 plus 2? What's 3 minus 2? Good. So the last thing in this lesson, there are 4 of these, is sometimes there are some numbers that we have to get out of the way so that we can use completing the square. So last 4 examples, and then you should be good to at least start your assignment. By the way, I'll be gone tomorrow, but only in the morning. I have a doctor's appointment at 9 a.m. So I'm going to have Miss Ferguson cover my morning classes. I think it's Miss Fergie. And I'll be back in the building, but not till like after lunch. I'll be here probably around noon or 12:30 or something like that. So anyways, I won't be here, but you guys will tomorrow continue working on this Delta Math, and then I'll also have a worksheet for you. So hopefully today you're learning how to do this so that when I see you later tomorrow or Wednesday, there won't be any like, stress or anything like that. So make sure you ask lots of questions today since I won't be in class tomorrow. Good. Okay. So I'm going to put some numbers now. Some new, and I have no idea like if this is going to stick out like a sore thumb, but right away, do you notice something that has, we've done probably 15 math problems now, 12. What's there that hasn't been there at all today? The 4. Right. I'm not worried about the 32, the 24, I don't care. But what's interesting to me that for the first time today, I hope you're still listening, is this number 4. That's a big deal. So what we're going to do right now, before we begin solving the problem, is we're going to divide all 4 numbers on the board by 4. We're going to divide here, 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 and here. And 0, remember, is nice like that because 0 gives no craps. 0 says divide me by whatever you want. I'm still going to be a 0. So what's nice about zeros? Well, it's one of many things that's nice about zeros. So once I divide everything by 4, I get x squared. What will be in the middle? Yeah. And at the back? Good. And at this point, you kind of go, back to normal. And here we go. So let's practice again. What's step 1? Yeah. So I'm going to have x squared plus 8x, awkward void, equals negative 6. What's half of 8? 4 squared. So we add 16. Okay, and I add 16 to the other side. Factor the left, what do you get? Nice. Negative 6 plus 16. And you'll find yourself actually starting to skip, like, I'm going to show you something here, and you're welcome to do what I'm about to do. You do enough of this, and you start to realize, like, I can make this the quickest method ever. You may not feel right now like it's the quickest method ever, but it is. And so I'm going to just write x equals negative 4 plus or minus the square root of 10. I bypassed a step that you're used to seeing right here. And I am going to write it, which I know seems silly to skip it and then write it. But what that step would have said would have been x plus 4 equals positive or negative root 10. But like if you already know it's going to look like that, then just bypass it, move the 4 over while you're thinking of it. Save yourself a little time. Okay. Just a couple more. And by a couple, I should have said a few because there are 3. What do we do first? Divide everyone by 2. So we get x squared. And by the way, again, if you don't mind watching, I'm going to skip a step. And if you don't like it, don't do it. I'm going to get x squared plus 16x equals negative 45. Like you and I know that 90 divided by 2 is 45. And then we also know that we're going to have to turn around and move that 45 to the other side. So why not do it now? What's half of 60? 8 squared. So we're going to add 64. The left side factor in 2. Negative 45 plus 64. So anyone bold enough to just tell me what my final answer is going to be if we skip that middleman step again? X equals what? Dope. Just like that. Once you get grooving, it's fast, or lightning fast, and it's so beautiful, this method. All right, let's do one. Actually, you know what I'm going to do? I want to look at delta real quick and just see something, if you don't mind. I'm just going to keep recording, though, because I want to see. Yeah, so I was going to show you, like, sometimes when you get to your delta math problems, you might see that the terms are a little bit out of order. So I thought I would get you familiarized with that. So let's say we had like this. There's going to be a little bit of extra stuff to do here. The bottom line is you just want to see big picture. What do I want this thing to look like? And if you haven't figured it out by now, the goal is that we want the x squared and the x to go here, and we want the number to go here, right? So going into the problem, if you know that, let's leave the 5x squared where he is. Who's going to go right after 5x squared? Minus 50x, because we have to pull him over to the correct side, right? And then we're okay with the 60 where he's at. So just be prepared to have to do a little bit of housekeeping or house cleaning before you start the process. Let's divide all the numbers by 5. What will my next line say? Go ahead and skip a step. What will it say? $60 divided by 5 is? So I'm going to move it over and make it a negative 12. Why not? What's the magic number? What's my red square completer going to be? Plus 25. Beautiful. So we add 25 to both sides. What's the left side become? Beautiful. Right side. And then you should be able to jump straight from here now to your answer. Makes it easier when the number's trash, like 13. It's a little bit more work if it was like a 20 or an 8 or a 24, but 13's trash. So what's the final answer? Done. Got it? Your assignment's on Delta Math. Shouldn't be an issue. And like I said, tomorrow you'll keep working on it. I don't anticipate or expect you to finish it today. If you do, sweet. But the plan is tomorrow you'll work more on this and then also dive in and get the worksheet done. The worksheet doesn't exist yet, but you'll have it tomorrow. I'll have Miss Fergie hand it out at the beginning of the hour tomorrow. Okay.